Bright QT. Every student matters.
Now, let us see how we are going to calculate or find out the values based on these particular things that we have already discussed. Coming to the numerical part now. Fine. Numericals based on parallel resistances. First, let us see. This is a resistance. First, this is a second resistance given to us. Fine. We have connected these resistances in parallel, right. This is a kind of circuit, plus minus, this is the amount of current going, anemometer probably can be connected over here. This is the resistance R1, this is the resistance R2. Now, we need to calculate or to find out a few things. We will see how. The arrows are to be shown while in a circuit diagram we are talking about. Let us take the values of this R1 and R2. Let it be a 3 ohm resistor and let it be a 6 ohm resistor, right. Fine. Now, at this battery we will be given capital V, that is the total amount of potential difference. Here probably we will be given total I, that is the total current. These R1 and R2 are given to us already. Fine. Now, as we have done in series, we need to relate that in this particular circuit there are a few things that we can find out. First, let us see only the simplest part. We are given to find the total resistance in the circuit. Now, when we are to find out the total resistance, we see that these two resistances are connected in parallel to each other, right. Now, students, in order to exactly know whether the resistances are connected in series or parallel, just apply one simple rule, right. Let us take a particular connecting wire. From here the current is flowing, current assume it to be flow of electrons. Fine. If the current is flowing and it is flowing in continuation, that means there is no possible alternative for the current to flow anywhere, then all those resistances are considered to be connected in series. For example, this was resistance R1, this is resistance R2, these are connected in series, right. But when I talk about this resistance R1, then resistance R2 and resistance R3, right. This was the resistance R1, this is R2, this is R3. Now, when the current is flowing through R1, right, at this particular point, now the current has two possible directions to go. Whenever this happens, that means these two possible resistances are always in parallel. Just like in this particular case, when the current was flowing from here, when it came at this juncture, this point, there are two possible directions of paths. One is this one downwards, which will be going through R2, and another is upward, which will be going through R1. So, therefore, we conclude that R1 and R2 are in parallel combination. And to find out the total resistance, we know that in parallel the total resistance is given by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2, where R1 and R2 are individual resistances and R is the total resistance. R1 we are given 3 ohms, R2 we are given 6 ohms. Just putting down the values, we will get, instead of R1 I can write 1 upon 3 ohms plus R2 is 1 upon 6 ohms, right. Taking the LCM, I will take the LCM 6, over here I will take 2 plus here I will take 1. So, that comes out to be 3 upon 6 and my answer after striking it off becomes 1 by 2 ohms. Now, a very important thing, students, because we are in a habit of putting up the formula and then writing is equal to this, is equal to this, is equal to this, and this will be our answer. No. Why such a big no? Because you need to remember that this is, you have been calculating 1 upon r till now. We are not asked to find 1 upon r, we are asked to find total resistance. So, you need to remember that after making up all the calculations, in the end you will take the reciprocal. So, taking the reciprocal, r will be equal to, same, taking the reciprocal here only, r is equal to 2 ohms. Got it? Always make sure, I have seen many a times the students, they just put in the formula is equal to, is equal to, is equal to, is equal to, and this is our answer. No. Always make sure that you are observing and checking as to what you are calculating. You have been calculating 1 upon r till now, but we are supposed to calculate r. So, taking the reciprocal at the end is very, very, very important. Number 1. Number 2, you have to always state the SI units at the end. Fine? Got it? So, this is how we calculate the total resistance. Now, had it been rather than 2 resistances, we are given 3 resistances. These are 3 resistances given to us, that is 2 ohm and 3 ohm and 5 ohm. They are connected in parallel. Once again, I am asked to find out the total resistance. The total resistance I will be calculating in the parallel combination, because I can see they are connected in parallel. 1 upon r is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3. Putting the values of r1, r2 and r3 in this formula, I will find that 1 upon r1 is 2 ohms, 1 upon r2 is 3 ohms, 1 upon r3 is 5 ohms. Now, taking the LCM, what I will be taking? Like, it is 30, I will be getting 15 above plus 10 plus 6. It comes out to be, just calculate, is 31 upon 30, this is 1 upon r. So, I will be making the reciprocal, r will be equal to 30 upon 31 ohms. That is my required answer. Got it? Fine. So, these are the few simple numericals that will be given based on the series and parallel combinations. Here we have taken the parallel one. Now, students, try to relate one very, very, very important thing. What? Let us see. If I am joining the resistances in series, I know I calculate the total resistances as R1 plus R2 plus R3 and so on. I am actually literally properly adding up all the resistances. So, the resistances are getting added up. Now, just take care of what I am saying. If I am talking about resistance in series, then the total resistance in series is always, and by saying always I mean always, greater than any individual resistance. We will take an example of it, just a second. Let us take, this is a resistance of 2 ohm, this is a resistance of 3 ohm, this is a resistance of 5 ohm, right. Now, if I calculate total R, it will be equal to 2 ohm R1 plus 3 ohm R2 plus 5 ohm R3, which comes out to be 10 ohms. Now, this 10 ohm is greater than 2 ohm, that is R1, this 10 is greater than 3 ohm, this 10 is greater than 5 ohm. So, the total resistance is always greater than any individual resistance. This is the first thing that we need to remember. Second important thing is, whenever we connect all the resistances that are with us in series and the total resistance, this is the maximum possible value of resistance that we can get. The maximum possible value of resistance is obtained how? By adding the individual resistances in series. Why? Because we are just adding up the resistances, right? But when we see the case of parallel combinations, the parallel combinations total resistance is calculated by the formula 1 upon R1 plus 1 upon R2 plus 1 upon R3. Got it? So, taking the same case that I am taken here, I will take 3 resistances now. This is of 2 ohm, this is of 3 ohm and this is of 5 ohms. When they are connected in parallel and when I found out the total resistance, as I have done in the previous question, I took that 1 by 2 plus 1 by 3 plus 1 by 5, that comes out to be 15 plus 10 plus 6, LCM was 30 and the value came out to be 31 by 30, and after reciprocating I got R is equal to 30 upon 31 ohms. When I am talking about 30 upon 31 ohms, then the value approximately will be 0.996 ohms. Now, this total resistance 0.99 is less than R1, is less than R2, is less than R3. So, when I am talking about parallel combinations, it is just opposite to the series one, that the total resistance is always less than any individual resistance. It is less than any individual resistance. That means total R will be less than R1, total R will be less than R2, total R will be less than R3. And the second way of saying is that the same thing is the least value, the smallest value of resistance is obtained by connecting it in parallel. So, now very important conclusion, if you want to increase the resistance of a circuit, right, then combine the resistances in series, because by that way the resistance will increase. Whereas, if you want to decrease the resistance of the total circuit, combine the resistances in parallel combinations, because this is how the so called total resistance will always decrease. Now, why do we want to combine these resistances, whether it is in series or in parallel? What is the need of it? Try to relate, please, right? So, for example, these are two different components. This is the first component, this is the second component, this is the third component. Now, this component requires a current of 1 ampere to operate. This component requires 3 ampere current and this component requires 5 ampere current. And for example, I am providing 5 ampere current. So, this 5 ampere current, when I allow in this particular component, component number 3, I will not restrict its flow. Why? Because it is going to work on 5 ampere. But when it comes to component number 2 or component number 1, now This is important. Why? Because if 5 ampere of current goes into these components, they will not be able to operate, they will literally blow off. And that is why where these resistances come into play. I will place a resistance over here which will resist the flow of current and will allow only 3 amperes of current to go into this particular component at a time. Similarly, I will place 2 or combination of 3 or a bigger one resistance over here which restricts the flow of current to a level of only 1 ampere which it requires. So, this is why we require these particular resistances and we require to make combinations so as to allow the required amount of current. So, whatever you are reading, try to relate it practically also as to where and why we use them. Got it? So, the conclusion is, if we want to increase the amount of resistance, we will always connect the resistances in series combination, and if we want to decrease the total resistance, we always will decrease by joining the resistances in parallel combination. Got it? So, this is all the theoretical part. I hope you have well understood it. Please try to practice and relate whatever is being taught, and next class, next topic, we will be taking up a bit of numericals based on the same concepts. Till then, please revise it. Thanks for watching.